Okay, so in this video I'm just going to have a look at the Junior Cert Higher Level Maths Paper 1 2017, and I'm going to have a look at questions 2 and 3. So first question here, question 2 here is: a sports shop buys t-shirts for €25, sells them for €49, find a markup for the t-shirts. And it tells you what to do here. It tells you to work out the profit as a percentage of cost price. Okay, so let's start. So we need a profit first, the actual profit. So the profit is just what they sold them for, which is €49, minus what they bought them for, which is €25. So that will give me €24. So they made €24 profit. Now we want that profit as a percentage of cost price. So in other words, the markup will be €24 as a percentage of the cost price. Well, it cost €25 and we want it as a percentage, so we multiply by 100, and that gives us a 96% markup. Okay, so that's part one, fairly straightforward. Second part says find a margin for the t-shirt. So this is the profit as a percentage of selling price. So we worked out the profit as a percentage of cost price in part one. So here we're working out the profit as a percentage of selling price. So you do the same thing again. We want the margin here. The margin, or percentage margin here, if you like, is the profit, which is €24. We want it as a percentage of the selling price. Well, we sold it for, or they sold it for €49, and we want to multiply by 100. So that gives us 48.9795 and so on. But we want this correct to the nearest percent, so that's going to give us, the nearest percent is going to be 49%. This is 8, there's a 9 after it here, so that will round this up to 9, so it's 49% here. Okay, the shop also sells runners or trainers at a markup of 50%. Find a margin for these runners. Give your answer correct to the nearest percent. Now, I'm just going to write a few letters down here. I'm going to say P is going to be the profit. I'm going to say C is the cost price, and S is the selling price. So it just saves me writing these out a lot. So we know that the markup here is 50%. And remember, the markup here is the profit divided by the cost price, which is C, times 100. And we know that this is equal to 50%. So let's just work out what the profit would be here then. So I'm going to divide both sides by 100 here. So that would give me P over C is equal to 0.5. Divide by 100 here, you get 0.5. Multiply both sides by C, that will give me a profit of 0.5 C. So that's our markup. Now we've got to work out the margin here. So the margin then is what? Well, the margin is just going to be the profit, and remember we have the profit here, 0.5 C. The margin is the profit over the selling price, S here, selling price, times 100. Well, what's that going to be? That's going to be the profit, which is 0.5 C, divided by the selling price. Well, what did we sell them for? We sold them for the cost price plus the profit. The cost price plus the profit. So if you just think about that, the selling price then is just going to be the cost price, which is C, plus the profit, which is 0.5 C. So we have worked out the profit here is 0.5 C. So the selling price is going to be the cost price, which is C, plus 0.5C. That's 1C plus 0.5C, that's 1.5C. So this is our selling price here, 1.5C. So our S here is 1.5C, and then we got to multiply by 100. So if you work that out here, you get, well, this C here and this C here will just disappear. You get 0.5 divided by 1.5 times 100, and that's just 33.3 repeated percent. This is our percentage margin here. Now it asks us here to give the answer correct to the nearest percent. So to the nearest percent, this would just be 33% to the nearest nearest percent. Okay, so that's question 2 done. Let's have a look at question 3. Okay, so question 3 here just starts by giving us a number, 868 million, and they want us to write it in scientific notation. So write it in the form a by 10 to the power of n, where n is an integer, n is an element of z, and a is between 1 and 10. A is greater than or equal to 1, less than 10 in fact, and a is a real number. So let's just write this in scientific notation. Well, 868 million is 868 with 6 zeros after it. So that's our 868 million. So what's that as written in this form here, written in scientific notation? Well, our decimal point is here. We got to bring it back to here. So we have to write our number a here between 1 and 10. Well, that would be 8.68, which is a number between 1 and 10. This part here, greater than 1, less than 10. Now we've got to multiply that by 10 to the power of something. Well, our decimal point is now here. We've got to bring it back up here again. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's just simply 8.68 by 10 to the power of 8. And really that's it. So we've written 868 million in scientific notation. Okay, next part then. During the Apollo 11 mission, it took approximately 1.3 seconds for a radio signal to travel 380,000 kilometers. Find the average speed of the radio signal in kilometers per minute. So you got to just watch these units here. We have seconds here, but they're wanting the answer here in kilometers per minute. Give your answer in the form, again, in scientific notation. And A is correct to 2 decimal places. Okay, so we can work out the answer and then deal with the 2 decimal places later on. So we have to find an average speed. So you may remember that speed is equal to distance over time. So in our case, our distance is, it's going to travel 380,000 kilometers. And kilometers is fine because remember, we need our answer in kilometers per minute. So we have kilometers, so we just need our time here at the bottom to be in minutes. Well, let's have a look at that. Well, we have 1.3 seconds, 1.3 seconds, and we've got to convert that to minutes. Well, there are 60 seconds in a minute, so what we've got to do is divide this by, we've got to take our 1.3 and we've got to divide by 60. And that will give us, I'll leave it as a fraction in fact, it's going to be 13 over 600. I'll just leave it as a fraction because if we convert to a decimal, we'll get a recurring decimal I think, but this is accurate anyway, 13 over 600, we'll leave it at that. So let's just put that in as our time here. So we're going to divide by 13 over 600. Okay, so let's work that out. When you work that out, I'll let you do that on your calculators yourself, but you get quite a big number. So it's 1753, 8461 0.54, and this is speed, and it's kilometers per minute. Okay, now we have our answer, we have our speed here, but now we've got to go back, read the question again, make sure you give the answer the way they want it. So they want it in scientific notation. So first thing we've got to do is just convert this to scientific notation. So we've got to bring this decimal point back here until we end up with a number between 1 and 10. So that would be 1.753846154. Now we've got to bring that decimal point back again. So we've got to bring it back up here. So how many places is that? Well, it's going to be 1, 2, 3, 4, 5, 6, 7. So it's going to be by 10 to the power of 7. Okay, so now we have it in scientific notation, but they want a corrected 2 decimal places. So 2 decimal places will be 1, 2 here. So this is a 5, and the number after it is a 3, so we're going to leave that 5 as 5. So this is just simply going to be 1.75 by 10 to the power of 7 kilometers per minute. Don't forget to put the units in. Okay, so that's part B. Let's have a look at part C. Okay, in 2016, a spacecraft flew around Jupiter, which is 868 million kilometers from Earth. Now you got to remember that this 868 million is something we dealt with in part A. We converted this to scientific notation, so I'm going to use that again here. Now find how many minutes it would take a radio signal to travel 868 million kilometers. Assume the radio signal would travel at the same speed as your answer to part B. So since we have part B in scientific notation, I'm going to use scientific notation for this as well. We've already worked that out. 868 million kilometers is equal to 8.68 by 10 to the power of 8 kilometers. Okay. So this is our distance that we're talking about. So this is our distance. Our speed in scientific notation from the previous question was 1.75 by 10 to the power of 7, and that was kilometers per minute. Now find how many minutes. So we do have minutes here and we have kilometers here, so that's fine. We want how many minutes, that's time. So remember again, speed is equal to distance over time, or if you do this triangle thing here, so some people do this, you've got so what do I do? Speed is equal to distance over time. So distance will be speed times time, or time will be distance over speed. Some people like to use this little triangle here. So we want time here, so we want time. So our time here will be distance over speed. So our distance divided by speed. Okay, so our distance is 8.68 by 10 to the power of 8 divided by our speed, which is 1.75 by 10 to the power of 7. So this is going to be our time. So this is a matter of knowing how to divide numbers that are in scientific notation. Well, the way you can do this is just simply split it up. You can take the 8.68 divided by 1.75, and you can multiply that then by 10 to the power of 8 divided by 10 to the power of 7, which is easy to do if you know your laws of indices, your rules of indices. So these two here you can divide on your calculator. You will get 4.96. 4.96. Here, if you remember your rules of indices, we're dividing powers here. So we're dividing 10 to the power of 8 by 10 to the power of 7. So you subtract the powers. So it's 10 to the power of 8 minus 7, which is just 1. So that's really just 4.96 multiplied by 10, which is 49.6. This is time, and we were dealing in minutes, so this is minutes. So to get a signal from Jupiter to Earth will take 49.6 minutes, so quite a long time. Okay, and that is it for these two questions.